Hello students, welcome to this session where you'll learn how to perform experiment 10 in your digital system design lab. So your 10th experiment is you need to design or realize a comparator circuit which compares two input numbers and gives the outputs whether the first number is greater than, less than or equal to the second number. So here we are trying to implement a 2-bit comparator using logic gates. So that will be the objective for this particular experiment. So since we are implementing it using logic gates, you need to know the operation of logic gates, the truth tables, how to design a combinational circuit using logic gates, and how to optimize your circuit. So these are the prerequisites which are necessary to design an optimized comparator circuit using logic gates. So you need to understand the basic operation of comparator and what are the various applications in which you need to use this comparator. So you can see that it can be used for password verification and biometric applications where our password, whatever we type, will be compared with the password which is already saved. Similarly, the fingerprints or retina scans, all these are nothing but comparator circuits. Similarly, when you're using sensors in industrial applications also, where if temperature exceeds certain value or goes below certain value, all these things. So these are the all applications of your comparator circuit. So here are some reference points produced. And coming to the apparatus required, now since we are we are building comparator circuit using logic gates, we need different set of logic gates to build the 2-bit comparator. So here we are taking an optimized design, and for that we need at least a minimum of 8 logic gates to design the comparator circuit. So you need XOR gates, NAND, NOR and NOT gates, so all 4 ICs. Then you need an input switches through which you apply A and B inputs, then output LEDs where you observe greater than, equal to, less than outputs, and finally protecting resistors. Then you also need power supply and breadboard, and finally connecting wires. So here I have given the pin diagrams of all the 4 ICs which you are going to use. And this is the circuit diagram which we are going to use to design the 2-bit comparator. So if you observe here, you have basically 8 number of gates. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in this 8 gates, you can observe you have 2 XOR gates. So this is one and this is another one. Whereas you have one XNOR gate, but we don't have XNOR gate IC in Tinkercad. So what we are going to do is we will use an XOR gate with a NOT gate to implement this particular circuit. So that means I need total of 3 XOR gates and 1 NOT gate. Okay, and here I need 2 more NAND gates. So this is one and this is other one, and here I need NOR gate. So 1, 2 and 3 NOR gates. Okay, so basically I need 8 gates, but actually I will be using 9 gates because of this XNOR I am going to use an XOR and NOT gate. So I have a total of 9 gates being used here. So this is the circuit diagram which I am going to implement. So please follow the procedure and connect the circuit as per the circuit diagram. See that there are no loose contacts while connecting the circuit, and observe your output on the LEDs which are given in the circuit diagram. So this is the experimental setup. I have highlighted all the equipment, what we have used, which ICs we have used and everything. So you can observe here, I have also highlighted what are your inputs and which LED is indicating which particular output here. Okay, so you can observe here the switch positions. Right now the switch positions are, so this is at 1, this is 0, and this is 1, and this is 1. So now actually this 1, 0 is A and 1 1 is B. So now according to these inputs, A is less than B. So you can observe here the LED A less than B is glowing. So this is the experimental setup, and just verify this particular truth table. So A, B inputs and what will be the outputs. This is what you have to do. Now let us perform this particular experiment by going to the Tinkercad environment and looking at applying certain inputs and looking at the output. So this is the setup which I have already shown. Now let me start the simulation. So if you observe, so right now it is 1 0 and 1 1. So let me make all the inputs as zeros. So when I am making all as zeros, so 0 0 0 0 both are equal. So A equal to B LED is glowing. Now let me make A1 A0 are 1 0. So 1 0 and 0 0. Now A is greater than B. Now if I make B also as 1 0, then again both are equal. Now if I make B as 1 1, so A is 1 0 and B is 1 1. So now A is less than B. So this is how you need to verify the operation of your 2-bit comparator, what you have designed. So coming back, the result of the experiment is you have realized a 2-bit comparator using logic gates and verified its functionality. Now the assignment for you would be you need to design a 1-bit comparator circuit using only NAND gates. That will be the assignment what you need to finish. And these are Viva questions which are provided here for your further reference for your placements and also for your gate exam. Thank you students for attending this session. Hope this session will be helpful for you in performing the experiment.